Hey team, our topic here is buffers, and we want to know how to draw them and what their properties are. All right, we got this. All right, I think when you think of a buffer, I want you to think of that it's a solution. All right, a homogeneous mixture. You've got something dissolved in a solvent. Your solvent's typically going to be water. All right, and your solutes are going to be a weak acid and a base, or a weak base and its conjugate acid. All right. You've got two or more things dissolved in here, actually. All right. So these solutions, you get your weak acid, your conjugate base, or your weak base and your conjugate acid. These things are the solutes of your solution. All right. Those are what's dissolved in there. Now, it's something that's really important about these things is that they don't react to each other. All right. Otherwise, you don't have a buffer. You don't have what you need. So an example of things that would react would be something like sodium hydroxide and hydrochloric acid. You put them together, they're going to react and make water and salt, literally salt. These two things won't react because they're involved in an equilibrium reaction. So here's an example. Vinegar, and it's the anion of it, all right? And since vinegar is a weak acid, it's constantly shifting back and forth, reacting. So you are reacting with you're not eliminating, and you're keeping your concentrations constant and changing. Where the opposite is ammonia, or another example is ammonia. NH3 is your weak base, and this cation is the weak conjugate acid of your ammonia. Now you can see these things are both conjugate. They're conjugate pairs. And the reason you would do this is because conjugate base pairs and acid base pairs don't react with each other. They form an equilibrium. All right. Now you can see what it says here. Like this acetate ion doesn't come out of anywhere. It's typically going to be with part of a compound. Same thing with this ammonium ion. It's going to be part of a compound, and they're called salts. All right. You could have lithium acetate, potassium acetate, manganese acetate. All right. All those things together with its conjugate acid will be a buffer. All right. A buffer, in terms of a particular drawing, you're going to have a solution like this, right? Multiple things dissolved. Now, both of these things are, particularly the conjugates, they have a spectator ion that's not shown here. All right. This is an acid one. All right. I'm drawing an acid and its conjugate base. I'm leaving out the spectator ion of my conjugate base. All right. It's often like a group 1 metal, and if it's an acid, it's often like your group 17 ions, like chlorine, fluorine. If you're talking about an acid, this is a base. Now, the presence of these acids and bases give the buffer huge properties. It's your buffer power. They can resist changes in pH. All right? Because your buffer, with these two pieces, any acid or base that gets added, you have a means to neutralize either of them. All right? And as my dear colleague said, and we'll get into this in another video, that there is a breaking point. It's not going to resist it forever, but it does have the ability to sort of to do it for a certain amount of added acid or strong base. All right. Thank you.